Hi everyone, just to say thank you for joining us. We're going to start in 3 minutes time, so if you want to get a drink or anything like that, we're going to start in at 2 o'clock British Standard Time, and we'll be back in 3 minutes. Okay, so it's 2 o'clock. We're going to start the presentation now. I'd just like to say good afternoon and thank you for joining us. We hope everyone in all countries and areas of the world are safe and sound, and that your businesses are operating as close to normal as possible. We've really delighted today to host this webinar alongside one of our system integrators, that is 3D Target, who are a technology company based out of Italy. They're offering LiDAR payload solutions worldwide, and they use our XOEM board set, the XOEM 550, in their Scanfly product. We'll talk a bit more about the XOEM products later. Paolo Girardi is on the call, the sales director at 3D Target, and he's going to be the one presenting today. He's going to take you through a description and an explanation of the Scanfly product range and also its workflow. So we're going to have time at the end for questions, but during the presentation, we have some poll questions that we're going to ask you just to try and gain a bit more of an understanding about why you've joined the call today, and what products you're interested in learning more about. If you do have any questions during the presentation, be sure to type them into the chat window on the right. I will gather them together and then ask them to Paolo at the end. And we've made sure that we've got time in the hour for him to deliver the presentation and then ask all of those questions. So be sure to capture them, and we'll record this presentation and distribute it to all of you as well in the coming days. So with no more delay, I'm going to hand over to Paolo, and he's going to give you the presentation on the Scanfly product.
Hello to everybody. Thank you, Paris, for the introduction, and thank you to everybody to join the meeting, join the webinar. So I want to start with the presentation, and I hope that everybody of you are safe, also by my side. So we can go and move to the first slide of this presentation regarding the agenda. So we will go through the fast introduction and then go with hardware and its sensor, how it's composed, Scanfly, subcomponent, and then we will go through the workflow from the field to the office, and all the application you can cover with usage of Scanfly. So you can start with the intro, and this is Scanfly, is payload lidar, as written in payoff, not only for UAS. So you can use it not only for drone application, but you can use also for other, survey. And so this is our main, intention when we start to develop Scanfly. So the keyword is easy to use, and we imagine a solution that's to adopt the laser scanner technology to the emerging market of UAV. But you can also use it on other vehicles. So that's we want to simplify the user experience and without sacrificing the system performance. So every detail is, designed and inspired by his philosophy. So easiness to use. So first type of using it is flying. So basically we develop it for UAV, but not only. And because Scanfly is composed by LiDAR technologies, and we need to find a good compromise between weight, consumption, and performance. And the flying mode is more demanding with respect to the other application, and need to be compact and need to be easy to integrate. And in our system, Scanfly, we put the LiDAR itself, 3D LiDAR, but we need to integrate even GNSS board, GLONASS and GPS, and laser scanner itself. So we have also the opportunity to integrate cameras, as we can see later. And this is the first prototype of the Scanfly we presented in 2016. And right now it's a little bit different. We are at the second version of Scanfly. And you can see here mounted on a standard quadcopter. In this picture, you can see the Scanfly itself, and the antennas, the GPS antennas on top right and top left. You can mount Scanfly on every drones, is drone agnostic. In this slide, you can see different type of drone, standard copter, ESA copter, quadcopter, even VTOL and fixed wings. Our customer, expertise very easy mode to integrate it in their drone. You need to install on your drone the Scanfly itself and the two antennas we provide in bundle with. Another option is putting on board. So using Scanfly like a standard mobile mapping system on a car, on a vehicle, and is complete mobile mapping system. And we can also bundle with cameras, and we are working on the integration of 360 panoramic imager. And on car, the main difference is the length of your survey. With the drone, normally you have 20 minutes, 25, even 40 minutes of flight for the longer flights. With the car, you can also run up to 8 hours of driving. And for that kind of application, we have dedicated mounting kits with an extended arm to avoid scanning the roof of the vehicle. And you can also change the tilt of the system. You can mount it on different vehicles. Here on a train, for example, and on a pickup. We can provide all the support to the integration in a different kind of vehicle. you can also use it in a backpack. So it's an optional kit, the backpack harness, to map difficult urban environments or natural trails or off-road, track. And we are working on the second version of the backpack, and we will be ready, was supposed in spring 2020. That situation, this situation of COVID, we are a little bit late, but we will go out, have the solution during summer for INS mode and before the end of the year with SLAM technologies. And what is inside the system, the sensor itself? So basically, the system is composed by a LiDAR, and this is the main difference of the three different models we are producing now. So the main difference is regarding the LiDAR head. So we will have three different LiDAR we mount on same box, the red, gray, and black box. The difference is basically the range of the system. So it's the light version, we have 16 channel LiDAR, Velodyne pack lights, and we have up to 100-meter range. With the HD2, we have 120-meter range, but 32 profile, so it means 32 LiDAR. And with Ultra, we have 200-meter range and 32 profile as well. The main difference is range, resolution, and the speed you can fly or drive is much more if you have more channel and more range. So this is the three different model I was speaking about.
Paolo, should we ask the first poll question there in case people know about the product already?
Okay.
So this is just the first of some of the poll questions we have. So if you are familiar with the Scanfly product or you're familiar with the Velodyne, we'll just give you 30 seconds to maybe vote which product you would be most interested in, so that we can capture where the main demand for the products lies. I'll just give it 30 seconds and then we'll move on.
Yes, yeah, we can also come back to previous slides, or better.
I think just at the moment
it's
shows
blocking,
this.
it's blocking. Yes, yeah.
Okay, we'll just give it a few more seconds and then we can go back.
Yeah, with 1632 and Ultra Pop 32, the main difference is the resolution and the speed you can drive for having more detail. Okay, thank you.
Let's carry on. Thank you.
Okay, so all of these models have this advantage. So every of the Velodynes can have multiple beam capability. What does it mean? That you have not only one LiDAR, like we are showing in this slide, but you have 16 or 32, beam LiDAR profiler. So with only one beam, you have this kind of problem. You are moving in that direction from left to right, and rotate a little bit the LiDAR head to take in one shot this and this surface. You are always missing this part, okay, this facade of the building. And look at how big is the shadow with single beam. If you have multiple beam LiDAR, so you have 1, 2, 3, 5, 6, up to 16 profiler here, and you can see in one way more surfaces, all the surfaces of this building, except behind, obviously, and look at how small is the shadow behind the car here. And this is the difference in reality, you know. How big is the shadow here, and how small, and how interesting is this part of the survey? You can see even inside the house. So because the different orientation of the beam, and the penetration is much more evident, and this is also interesting if you think about surveying by the top. The red lines on the top here, I suppose you can see my mouse pointer, is where the drone flew, the trajectory of the drone. And you can see there are a lot of points even behind the trees and all over the area, for two main reasons. One is the multiple beam, so different angle allow you to have a different point of view, and you are accumulating the resolution and the number of points per meter square moving in the direction you want, because you have multiple beam. If you have only one beam, only one shot that is going here, okay, so you have this kind of visibility, for example, on these trees. Another big advantage is the dual return technologies. So let me explain a little bit what's happening. So if you have the LiDAR, every LiDAR have a pointer, a beam diameter that is approximately, for Velodyne, 2 centimeter diameter. Okay. So if you scan, for example, this surface and implant, and this is the source of the LiDAR, go there and you have this footprint, then you have another footprint like this, okay, and here on the edge you have this, okay, and then the last part of the pointer, the other half of the point go behind the edge on the other surface, on that surface, okay. So with single return, what's happening, that there will be an average, so the scanner understand that the point is here, so a stupid point. So with dual return, you have this and this option. So you are not losing any shape, otherwise you have only this right pointer, and try to imagine it's like during a survey of the trees, if you are on a surface where there is the grass, a field, so like this. So every single object is thinner than the pointer, so we lose a lot of points because the software automatically canceled that one. So with dual return, you have all the information regarding the canopy and the ground in one shot. Okay, so the first return is the strongest return, and the last return is the less power last return. So this is the difference. This is the picture on the left is the in red. You can see the first return. In blue, the last return. And basically in this cross section, you can see how many points is here on the ground. Even if the position of the sensor capturing, was done by here, you will have this and this point, okay? And even, the multiple beam allow you to describe better the surface, okay? And the Scanfly, the LiDAR is moving like this. So again, look at how many points the system capture even during the the movement. Okay, this is an example of a real example of this survey. You can see later in the application section. Again, red lines are the trajectory. This is the raw data coming from the LiDAR with no filtering, and on the right we filter out the vegetation. So you can see how many points are on the ground. So how many points pass through the canopy, pass through the vegetation, it go directly to the ground to generate a proper DTM. So another feature regarding of the Velodyne is the calibrated reflectivities. So the scanner itself generates XYZ, or better, a distance measurement with angle of the firing position, and can capture the quantity of lights that come back after is reflected by surfaces. Okay, so if you are firing a white surface, the return will be 90%. If you are firing a reflective surface, is 95, for example. If you are firing a black surface, it could be 10, 50%. And all of this data is used for generating a gray value map. But the most important thing is that independently by the distance, Velodyne generates reflectivity, information that is always the same for the same material. So it's very useful to generate and create an algorithm to automatically extract the reflectivity, retroreflectivity surface, like the vertical sign, like car plate, and so on. So the first part of the Scanfly is the LiDAR, but probably the core of the system is the absolutely the core of the system is the INS, Inertial Navigation System. We need it to understand where we are during the survey, and because knowing the position, we know where we are firing with the LiDAR. So we need to have the position. So we choose OxTS INS that integrates an IMU, National Measurement Unit, and GNSS system. The board itself is the XOEM 550 that integrates inertial measurement unit with accelerometer and gyro, and two receiver L1 double frequency, L1 L2 with GPS and GLONASS capability. It's tidal coupling navigation engine. It allow when there is no GPS signal, no GNSS signal, we can know exactly the position without losing accuracy, and is really good to have a board that we can control in all these all of the parameter. So this is the benefit we can find using OxTS board. It's dual antenna. So when we start the system, we need to know where we are and the orientation of the system, because otherwise it's happened like when you start your mobile phone and you try to navigate with the navigation system, and 90% of the case you start and you are in a positive direction that you are expecting. So because the system doesn't know exactly where are the direction of your movement, after a few seconds he can understand. In this case, we need to have much more accuracy, and with two antennas, you understand in one shot, as soon as you have the GNSS signal, where you are and the position of the and the orientation of your system. with dual antenna, you are not forced to do, the figure eights that allow you to understand where you are, as I told you before. So you have a longer flight time, less battery drainage, and again, you are extending the time of flights. And because it's a measurement instrument, it's really important, even the performance, so that it's really good. And we can really, confirm to you that this is absolutely realistic. In some other spreadsheet, in some other producer provide not so, realistic information. And one of the most important thing is even the weight for us, because we need to fly, so we need to put everything in less weight than as possible, and it is, even the dimension is really, really important. So another, very, very good, option of the OxTS board is the integration that we can do in our system. Is fully integrated, and we can control everything. It's common that producer provide us, that OxTS give to us. So we have full firmware common list, so we can change all the orientation, all the lever arm, everything is under our control. It's really important for us, like an integrator. We can give to the user the free of changing everything easily. Even by software side, OxTS provide a very good tidal coupler navigation engine, and with the well-known GX IX technology is, as soon as you have GNSS leakage after under tunnel or so on, when you come back to the open space, open sky situation, you will have a fast relock, and even you have a very few satellites, it's really useful tool. And we can integrate all the process of post-processing in our software because the dedicated SDK. And another good thing is that when we process the data, we can use multiple different method, like RTK or PPK, post-processing kinematic, and in combined mode with different option. Continue to describe the products. Part of the product is the integrated board that can control the system, save the data, synchronize the sensor, and the software itself is provided, including the package. There is OxTS NavSoft suite. Is a full suite of software to generate the trajectory about the inertial navigation system, and smart processing lidar is our own software for data fusion. So for merging together lidar data and INS data, camera data, all the stream is go inside smart processing and let us to generate a 3D consistent georeferencing point clouds. So yeah, carry case, customized mounting interface. So we provide a dedicated mounting interface for different application, for drone, for car, for an easy installation on any vehicle. So we have the option of the camera to colorize the point cloud or to get pictures with high quality for generating 3D map with photogrammetry stuff. We provide the images and the external orientation and internal calibration to go through in third-party software and generate an orthophotos or something like that. And we are capable to integrate different sensor and standard RGB camera, like multispectral camera, like IR camera, is because the capability of the sensor and the IMU to trigger out and triggering the different sensor. So we can try right now to explain to you a little bit about the workflow. What is the standard workflow to make a proper survey with Scanfly? So we try to sum up everything in this slide. So starting from the field, from the left to the right, we have the Scanfly itself, and we have a web app or a smart survey that is our software that can control the Scanfly through Wi-Fi. We don't need to have cabling or some other connection or computer in the field, but we can generate a Wi-Fi network by Scanfly itself. You can connect through the web app to the Scanfly, and one of the most important things during the survey for us is be aware about what's happening inside the system. So if we are in a good condition, if you are in a good GNSS condition or not, if the IMU is properly initialized or not, if the camera is well connected or not, if you are ready to fly. Then when we are in a car, for example, it has no sense to have Wi-Fi because we want to have, for example, some other option like point cloud in streaming, live streaming of the point clouds. We want to see what's happening in the survey. We want to have a map. So we need to have, and we can have a desktop on our car, on our vehicle, and we can have this connection with a software that can control by a standard PC all the Scanfly. Those software are have the same features. With Smart Survey, you have some option more. On Scanfly, you have the opportunity to connect a camera, as I told you before, and we recommend in the field to make a survey even with the help of GNSS base station to improve the quality of your system. And you can have the RANX file from your own base station. We need the RANX 1 second, every 1 second measurements, and or you can also download the RANX from the course network. At the end of the survey, we can go inside the software in the office, or we can also try to have a double check of the system, a survey in the field. We can open OxTS NavSolve suite provided by OxTS, or jumping directly in Smart Processing Ladder to import the data from the IMU and GNSS from Scanfly, the RANX file, and then generate the trajectory. After that, you can merge everything together, LiDAR, images, and configuration file. Go with trajectory inside Smart Processing Ladder to generate last with intensity or RGB value. LAS is a typical file format. It's an open file. It's not open, but you can import in a lot of files, but in a lot of software. It's a typical file format for point clouds from mobile mapping application. And you can have, if you have a camera, JPEGs with orientation, and with these two outputs, you can go in third-party software to generate the deliverables. So we want to ask you right now in our poll if you have if you are familiar with point clouds data processing software. Because we provide that kind of output, and so you can also run in your own software. A lot of software right now have a point clouds engine to edit directly inside a specific software, these kind of outputs. We want to be open in outputs, so we decide to go with standard format. Okay, I can move.
Yeah,
next slide. Yeah, in the field, so installation is very easy. Here you can see the quick mount adapter with you can mount on every drone with 4 screws. Here is a typical installation. I think that this is DJI Matrix 600, and after the installation, here's some example of installation. You can start to make the survey. So some other installation to show you before, even on a car, on a train, different angle, different orientation. And here you can see even some example with camera. Okay, we have 2 options. We have a global shutter camera, industrial camera, and we have Sony Alpha 6000 and Sony Alpha 7R for basically drone application. And
we just want to capture there, Paolo, which product, which vehicle people would be most interested in using the system on?
Yes, my apologies.
Okay.
Yes, if we are asking you if you are interested to work basically moreover on drone or car or even on backpack. And so for mounting on a car, we have the option to have vacuum, suction cup, or other kind of installation with clamping solution with magnetic system. And you can also, as I told you, mount easily on any kind of vehicle. For example, here our customer decide to do the integration with themselves. So we provided drawings of the object of the Scanfly, and they can do the integration kit by themselves.
Okay, we'll close this poll now. Okay.
Okay. So for surveying, in the field, there are 3 main steps to do. One is setting the mission of your drone. Is not depending by the Scanfly, but because Scanfly is dependent by any drone, so you can do your mission plan with your standard software of mission planning with your drone. You can switch on the Scanfly, and you can connect through Wi-Fi to your Scanfly, and opening a standard web browser, you can configure everything about the Scanfly. So we can see later a web app application to control and to check everything. So here is the main page of our web application. So allow you to check the status of the system with simple traffic light here. So when you have green light or yellow light, you are ready to press record. This warning button became record button. Before starting, you need to configure your system. So the position of the antenna and the system respect to the main orientation. So you can do it easily here in this page, and you can save the profile. with the name of your drone or what else. And when you come back the next time to make the survey with the same equipment, you can load this profile, and all of this application is restored. So here you can set if you are working with 2 antenna or not, where there is the second antenna respect to the first, and the distance between the primary and secondary antenna. And basically here the position where you can also select if you are using the system by car, by UAV, or by backpack. The good thing is that the firmware of all the components can allow us to work like this easily and without any problem of difference in firmware package. So by LiDAR tab, you can configure the speed of the LiDAR, how fast need to rotate the scanner if you want to have a dual return, and there is a calculator of the resolution, estimated resolution on the ground. So if you are flying at 70 meters and you are with 17 meters per second, with this number of rounds per minute, you have this kind of resolution. So you can calculate, have here the resolution, so 37 points, because we are flying very fast. Basically, if you fly at 5 meters per second at this altitude, you have more or less 200 points per meter square. I apologize. So here you can see even the distribution of the points during the landwise and transversal resolution respect to the main direction. Okay, this is the main direction, this is the resolution, this one resolution, this is the other resolution. Okay, transversal resolution and landwise resolution. So you can also control the camera. If you have you can set the position. You can set different light presets, and you can also calculate as well the resolution, expected resolution, and respect to the speed and the height of your survey. After the survey, you can verify the completeness of the acquired data. You can go to dataset tab and you can see how big is the data, if it's consistent or not, how many space you have on your drive, and if you need to remove some folder to save space, you can do it. We provide Scanfly with 500 gig standard default internal hard drive. You can have access to the manual as well to do the proper thing during the survey, and you can also do upgrade the firmware version if you want, and setting the storage and some other option. Okay, this is Smart Survey, more or less the same thing than web app, but it's a desktop software you need to install on a computer. You can connect through the Wi-Fi or J45 cable to the Scanfly. If you are in a car, you can easily use it. You can load the KPML file, KBMZ file, to know what is your path to follow, your track to follow. You can see here on the right the map where you are, and the red dot is where you passed through before. And here the real-time point clouds. There's also the capability to have RTK correction if you are connected to a base station or to a course network. It's really depending about the connection stability. So going in the office, this the same slide than before, just to be sure that we already done this part. Okay, we are ready to go in the office. So first of all, we need to start with processing the trajectory. As I told you before, we can do the processing inside the Smart Processing LiDAR, but we also provide the OxTS nav suite software to better set all the parameters and to generate a consistent trajectory. So just a second. This is a video tutorial that show to you what is the step of processing. This is the standard raw data folder of the Scanfly. In Rhinex is the data coming from the base station or course network. Just to have a look, is standard Rhinex formats. It's okay. It's 2.11 and the version, and here you use that one to import inside the NavSoft suite with the trajectory raw data. So you import that, you go and import the Rhinex file, and you can generate the consistent trajectory estimation. So we have different methods. You can import multiple Rhinex file in one, and only one is depending by you. So, and then here we can use the simulated process or combined process. Combine and is the processing the data from start to end and from end to start, and to make an average using different configuration of Kalman filter, and to increase the quality and to avoid problem during some GNS avoid time in the survey. It's very, very fast, this processing. At the end, you will have a trajectory file, in even exporting in CSV file, and with combined mode, we smooth the peak of the error during the survey when we have no GNS signal. Okay, so we can review the quality of the data of our processing, and we can see here underlines that all this survey is in this GX integer. It means that we have a very good solution. The base station and we are using and the Scanfly itself have a good correlation, so we can estimate that the accuracy, final accuracy, is less than 2 centimeters. Okay, so we have this file, that encom file, that is ready to be imported inside the smart processing lidar. This is smart processing lidar, and it's a software fully developed by 3D Target, and is to process data and to merge data from different sensors. So here you can see the first slide when we can open the projects, and again here is a video tutorial when you can see better which is the step-by-step process. So we can open the folder where we have the raw data, so and then go through the okay, all the next step. So here we can find the path, standard path. The system already know what is the trajectory file format. We can also import a different calibration file. Good thing of Scanfly is that you can calibrate your system by yourself, and then press next. And if you have some camera dataset, we can import the JPEG. So the software is importing everything, is calculating the synchronization, and then generating the map of the lines and the graph on the top, the diagrams on the top, to see the quality of and the estimated accuracy we can have. So here on the top, you can see the diagrams to verify the quality of the surveys. I told you, you can see a lot of information, and then we will go through defining the lines we want to extract. So in the maps, we can select the portion and we can review the quality of every part of the survey. So switching even to Bing map with hot photos, and then we can also review the camera. So in the 3D viewer, we have a preview of the final results with the superimposing of the camera, if you have the camera. So here is exactly where we are doing the calibration process in our warehouse. So you can see here the 3D point clouds, and you can switch between perspective view and orthographic view. You can see the projection of the point clouds, and you can increase the resolution, the point size, the subsampling, and this is only the preview of the result. And then here inside the system, this window, you can also calibrate the camera. So if there is a problem of misalignment of the camera on the top of the point clouds, you can review all the survey and do even the calibration, adjusting the coordinates. Okay, I'm moving forward. So here is the part of the video, the tutorial that can give to you the opportunity to select the starting and the ending point. In some case, you need to have the curves and part of the survey, so you can select part of the survey you need, and then you can export all your point clouds in LAS file or LADS file, compressed, selecting the automatically UTM zone, and you can have different elevation type, ellipsoid or geoid, and you can select also portion of the 360 scanner. So instead of having all the 360, you can have also only the bottom part facing to the ground. And then you can select if you want to have color or not on the point clouds. And the software generates for every export subfolder in your main folder with 4 or 5, depending by line number, different LAS file. Here there's another export with the color, before was without, and with generate line buttons you can export your files. Okay, so generate another folder with different LAS file. You can also use gray value and RGB value together. So this is a very useful tool we introduced last January, the opportunity to calibrate in semi-automatic modes the position of your heads of your LiDAR respect to the IMU. We calibrate the system before shipping, but if customer move the head, rotate the head from 0 to 30 to 16 to 19, it's one unique feature of Scanfly. You can do the process of bore sighting by yourself. The bore sighting process is let the system understand where is the sensor, the LiDAR, with respect to the center of the IMU. So it's quite easy tool. You need to select points of different planar surface, and then simply clicking some points, the system understands the plane itself, and we need to have two-way survey, so same area surveyed by in two main direction, and then the system can do the calibration itself, so calculate the point that minimize the error. And then you can update your calibration file, and 3D TC is the calibration file we are using, and even for the next you can use this calibration. So the application. So this a short list of the application you can apply the Scanfly on. So I don't know you guys in which application are more active or you want to have a solution for. So we will have another question of our poll. He can provide your answer. Could be very useful even for developing some specific tool for everybody of you. And yeah, we can apply Scanfly. Our customer is applying Scanfly in topography, DTM generation, precision farming, forest survey, cost survey, and road cadastre, monitoring, BIM, tactical survey, asset management like power line survey, bridges survey, virtual tool generation, 3D reconstruction. There are plenty of applications that could be useful. LiDAR itself is very, very useful in forestry survey, in power line survey, because it's photogrammetry stuff cannot do better. It's really hard for photogrammetry stuff generate a proper survey of, for example, very thin cable of the power lines, or in the forestry mapping, you have no the dual return capability. So LiDAR is very, very useful in this kind of application, but also in coastal survey, where you have different material, different angle, you can also very easily scan with LiDAR. So if you want to go in our website, www.scanfly.it, you can see some example under application, and you can browse and navigate in 3D in a 3D engine on your browser some data set our customer did with Scanfly. So you can also use easily. So right now we are going through some examples just to let you know our customer application. This is an example of high voltage power lines, fly modes. So by drone using an hexacopter, so probably it's a DJI 3600 Pro. It's Scanfly light, 5 meters per second speed with dual return mode and Rhino correction for a coarse network. So the project is more or less about 20 kilometers, made with 8 flights, and flight AGL, the altitude is 20 meters above the wires. So for avoiding interferences with electrical field, electrical interferences, and to have a right resolution. So the ground distance is more or less 50 up to 70 meters. And this is, the video can show you the live 3D point clouds. It's part of the 20 kilometers. You can see very, the cables very well. So, and you can see the resolution on the ground. You can see even the, difference, shape of the mountain. So this project was done by our customer to provide a clash detection, a clearance detection with vegetation. So here you can also have a look on the profile. The accuracy of the system is really depending about the G and S condition, but is inside 10 centimeter global accuracy. The compactness, the noise of the point cloud is plus minus 2-3 centimeter up to 5 centimeter. but it's really depending about again the GPS condition in the best practices that you are using for avoiding not good situation. So we recommend to go out with at minimum 6 satellites visible. So there are mission planner that can provide you how many satellites will be in that time. So we recommend to use the best practice to avoiding, problem processing. Here is a very basic tool can give to you the access to have this information. After this, acquiring the customer, making the vegetation difference checking, and provide to the final customer a report like this with the distance, average distance of the wiring respect to the vegetation, if there is clashing problem or some other kind of interferences. We can go through the next example. We are a little bit late in the presentation, but I go faster. Here is a survey of a river example using Scanfly Ultra. So we can move up to 120 meter AGL. So consider that 100 meter, it means that you can have this distance between the Scanfly and the ground is 100 meter, but you have also this kind of measurements, so you can you can go up to 140, 150 recommended AGL, and you need to consider that the distance is that one, maximum distance. And again, here you can see a video, just a second. Okay. In Quick Terrain Modeler is a third-party software, and you can easily review the data, and you can also easily apply filtering and here the cross section to extract and move out the vegetation. In this case, this survey was performed for redoing part of the river border, and they need to have the DTM without the vegetation. And so here you can see how the system is performing a very fast filter out, so you can classify the point clouds and generate only the DTM you need, not the DSM, so not the surface but the terrain. Okay, so you can see here, you can, after this processing, move out the trees from the survey. Okay, forest application, 5 meters per second quadcopter survey with Scanfly light, 30 meter altitude. And again, here is to generate DTM. So starting from raw data and going to filtering out here. Okay, you can see the raw data. So, and with the vegetation, and here you can see how many point is on the ground, and here is the data filter out. So only the point that go to the ground and was fired on the ground. So look at how many points, because dual return and multiple beam advantage. So, and after you can generate a mesh triangulated model, and you can export in your CAD, or generating a cross section and so on. So, an example, you can put your system on your car, and you can make downtown survey. So I think that this is a survey made in 15 minutes. So you can navigate inside the survey. You can see, very, detailed survey, And as I told you before, because the calibrated reflectivity is very easy to find out the vertical sign and then horizontal sign, and this system is very useful for mapping all the component of the cadastre of the city, and you can make cross section, you can make whatever you want, even classification. And here you can see the grade value. So and then you can generate cross section and all, starting drawings for your project. An example of the survey made by Railroad with HD scanner, 2014 kilometer towards